guys. Welcome on board. Dávide Frísoli here from Madrid, Spain. And welcome to this jet orientation course for Airbus A320. We're gonna see the fourth part today. And it's gonna be about electrical and hydraulic system. First of all, I know we are not living good times nowadays, let's say strange due to coronavirus pandemic, COVID. So I would like to give my best wishes to all of you, your family, your friends, and hope that everyone is good. I want also to say hello and thank you to all of you, because I know a lot of you are watching us today from other parts of the world. So here is around 10 in the morning, but it's not the same time all around the world. So for this reason, hello and thank you again so much to take your time for being with us today and for trusting in GTA once again. I would like to introduce myself very quickly for those people who don't know me. As I already said, I'm Dávide Frísoli. I'm 31 years old. I've been working in GTA since 2012. Well, I was working 2 years in the office department from 2012 until 2014. After that, I started flying the Airbus A320 in Iberia Express, a short-haul Spanish company. I've been flying there as a first officer for 5 years. After that, I started flying again Airbus A320, but in Iberia, short-haul and long-haul Spanish company. And since October last year, 2019, I started flying the Airbus A330 as a first officer on the long-haul fleet. By the way, nowadays I'm current on the Airbus A320, so at the same time I used to work with GTA as theoretical knowledge instructor and as a A320 type rating instructor. I know today you're seeing my face on your screen, on your smartphone, on your laptop, whatever, but I really hope to have the opportunity to see you in the next future, maybe in one of the GTA simulator centers, in Jakarta, Indonesia, or in Bogota, Colombia, or why not here in Madrid in our headquarters. It's gonna be great, and I hope to have this opportunity in the future. By the way, we're gonna start with the lesson for today. As I already said, this is the fourth part of the jet orientation course. I'm gonna select my screen and I will switch off my video to have better connection with all of you. And at the end, I will say bye-bye again. Okay. So, welcome again, guys. First of all, don't worry about this course because the minimum level required is very accessible for all of you. And the minimum knowledge you have to have is a commercial pilot and IFR license or something similar. If someone of you is still studying to become a pilot or is thinking to do it in the future, it's fine. It's true it's gonna be just a little bit techniques in some aspect about the A320, but I hope everybody can learn something new today and it's easy to understand for everybody. It's an introductory course based on A320 and it's divided in 5 parts, 9 sections. Today we're gonna take a look to the section number 7 and 8, and each conference takes around 50 minutes. I will try to get that time score. The index, very quickly in this part, you have probably already seen some chapters in the last week on Monday, Wednesday, and Friday. We had performed the section number 1, 2, and 3 with Davide Aguinaco, jet and propellers differences, jet aircraft aerodynamics, performance affecting jet aircraft. The second part was performed by Paco Espinosa, Airbus 320 aircraft general and auto-flight system. And the third part, last Friday, with Davide Aguinaco again, Airbus 320 flight control system. Part 4 is the one we're going to see today, electrical and hydraulic system. And the day after tomorrow, on Wednesday, you will have the opportunity to watch the last part of this course, A320 maneuvers and some related procedures with Paco Gonzalez, our head of training in Indonesia Training Center. A very good person and experienced pilot. You will learn a lot for sure. By the way, don't worry, this course is a virtual tool for all of us. We are not gonna do an exam. I'm not gonna do some question to you. You don't have to answer me. It's just a webinar course, and the final idea is that you can catch some new learning today and interesting stuff about electrical system and hydraulic system for the A320, and are one of the most important system of the airplane. So that's the idea, and I hope you can enjoy the course. Well, let's start. Section 7, electrical system. That's a diagram about the electrical system. I choose 3 diagrams. This is the first one. Later on, you will see other 2 similar to this one. By the way, the electrical system, as you can see here, we have 2 colors, orange and blue. The orange part is referring to the AC power, and the blue part is referring to the DC power. This aircraft is working, all the system, the majority of the system are working with AC power. But if something goes wrong, we always have DC power that can also produce AC via the inverters. But basically, as a general idea, remember AC power is the main electric power of this plane, and we have also DC power for other systems. For example, the batteries are obviously giving DC power, but we have other systems as well with that current. Remember, the electrical power system of the Airbus A320 is a 3-phase, 115-200 volts with a constant frequency of 400 hertz. And this is for the AC part. And the DC system is working with 28 volts. In normal operation, as I already said, the system provides AC power via the main generators, generator number 1 and generator number 2, that are engine-driven generator. That means that they are inside the engines. Then we can see here an APU generator and an emergency generator that we can use it in emergency situation, the emergency generator and the APU for this engine startup or for other situation, air conditioning, and also emergency situation as well. By the way, we're talking in electric sense. I mean, APU can give us air conditioning, but now we're just talking about electricity. So remember, the APU is like another little engine with another itself generator. Later on, we're going to see it. This is the electrical system diagram number 2. It's quite similar to the other. And we can review again. We have generator 1, generator number 2, APU generator, emergency generator, and how the currents goes in the system. Well, generator 1 gives electricity, AC power to AC bus 1, generator 2 to AC bus 2. Then we have transformers. We have transformers 1 and transformer rectifier 2, and essential transformer rectifier. The essential transformer rectifier works just on emergency, and normal operation works with transformer rectifier 1 and 2 that are transforming and giving AC power to converting AC power to DC power to the DC bus 1 and DC bus 2. The DC bus give electricity to the DC bus that give electricity as well to the batteries to charge them. And here we can see we have a static inverter that is used when we lost all the AC power on the aircraft. So we are flying, for example, on batteries, and the batteries has to convert the DC power to AC power. So the system uses this inverter to convert DC to AC. So remember, as general idea for you to know, transformer rectifier converts AC to DC, and inverters are exactly the opposite, converts DC to AC. So that's the most important thing I think. This diagram is quite easier, very simple one, less information over there, but anyway, you can see exactly the same information. Generator 1, generator 2, how AC power works in which part, and how DC power works in the other side via the transformer rectifiers. Three main generators. Generator number 1, generator number 2, engine-driven generator, we already said. They are driven by IDG, each one. The IDG is an integrated drive generator that maintain a constant speed of the generator. And then we have the GCUs. GCUs are generator control units that control the frequency, the voltage, and protect the network. And as you can see here, the APU, it has own generator inside, but it doesn't have, IDG. So that's the difference. And these three generators, all of them are three-phase, giving 90 kVAs at 115 volts and 200 volts with a frequency of 400 Hertz constant frequency. If you remember, on the diagram, we have seen an emergency generator. The emergency generator is used on emergency situation. We still don't know what happened. Probably all of you have seen the accident happen in Pakistan 3 days ago to Pakistan International Airlines. We have to wait for final reports, but as you can see, I probably had the opportunity to see some picture about that accident, and the aircraft had we can say little propeller outside of the belly. This is the ram air turbine. Later on we will talk about it in this chapter and also in the hydraulic. And this ram air turbine is exactly moving the is moving the emergency generator we are talking about right now. So remember, emergency generator works in an emergency situation. We call emergency for that reason. It's a three-phase with 5 kVAs in that case, not 90 as the normal electricity in the system. So it's a very short power in this case, but is enough to control some basic instrument, at least the left-hand side of the captain, to permit the pilot to land the plane safely. And we have 115 volts, 200 volts with 400 Hertz. But as a general idea, we maintain some electricity on the systems, but it's a very short power we have in this case. And we have also a GCU, generator control units. Remember, we have seen on the engine-driven generators, the emergency generator has as well control of frequency, speed, voltage, and protection of the network, thanks to the generator control unit. Now we're going to talk about the static inverter. I said already something to you. If you remember, I said when we're flying on batteries, batteries has DC power, single phase, 115 volts, 400 Hertz. And when we're flying on batteries, we need AC power on the system. We cannot fly just with DC. So the static inverter is what it does. Convert the DC battery power to AC power and feeding the AC essential bus. I didn't say it before, but we have also AC essential bus and DC essential bus. They are used in some electrical failures and some emergency. During the type rating we used to work with, so if someone of you have the opportunity to do an A320 type rating in the future, you will see exactly how the aircraft perform these failures. And basically, you have to clear in mind that static inverter converts the battery DC power to AC power to the system. Furthermore, remember, if we are above 50 knots, remember that the static inverter, it's working, regardless the battery 1 and 2 switches position. Later on, we will see the battery switches. And if we are below 50 knots, it's work just if the batteries are in the auto position, that is the normal position of the batteries. Remember, we talk about static inverters, and his cousin, to say in some way, is the transformer rectifier. We have 3 identical transformer rectifier, transformer rectifier 1 and 2, and the essential transformer rectifier. They took AC and they convert AC into DC, and remember the transformer, the essential transformer rectifier works when transformer 1 or 2 are in ops, or if we have a total generator failure in the plane. They have an input of AC 115 volts and a maximum output of DC current 200 amperes with 28 volts. They also have an auto protection system in case of overheat. I forget to tell you. Well, the DC power batteries. We were talking about batteries, static inverters, some stuff related to the batteries. And well, batteries, we have 2. I already said 24 volts, 23 amperes hour. The minimum voltage requires 25.5 volts. You will see during the course, during type rating, or during your jet orientation course, you will see that during the preliminary cockpit preparation, it's one of the first steps the pilot used to do. You will have to check the battery voltage, and if you have 25.5 or more, no problem. The system is charging good. The battery are operating in a good way. If you have less than 25.5, you have to charge the batteries probably with external power and performing a 20-minute charge to the batteries. Anyway, you will see exactly during the course on present. And for you to know, we have an auto cutoff system if the voltage is below 22.5 volts. And if we are flying just on battery, imagine we have lost both engine, we are flying with batteries. We have approximately 22 minutes to be safe on ground. Later on, just in the next slides, we were talking about the circuit breakers, and we're gonna talk about some circuit breakers that in the case to fly on batteries on the old RAT version or old A320s planes, we can save some minutes more for the battery. I'm gonna tell you right now. Well, DC power circuit breakers, they work with DC currents. We have 2 main circuit breakers type, the black and the green. Black circuit breaker are not monitored by ECAM. The ECAM, remember, is the electronic centralized aircraft monitoring system. So if we have some failure, something is going wrong on the plane, we have immediately, in the majority of the case, we have an advice on our ECAM screen. So if we pull out black circuit breaker, we don't have message on the ECAM, nothing like that. If we do that with the green circuit breakers, remember, we're gonna have an ECAM caution because they are monitored by the system. So an ECAM and an oral warning, a single chain master caution will sound in the cockpit to catch the pilot's attention. All the main system has circuit breakers, as you can imagine. And here we have other two types, the wingtip brakes, red color circuit breakers. We have 4 in the rear cockpit panel. And remember, wingtip brakes, I guess David Aguinac on the 3rd lesson talked about it. It's referred to flight controls, but just for you as a general idea, wingtip brakes are devices that avoid slat and flap asymmetries during the flight. So that's how it works. And why we have a red color? Because we can't touch it in flight. It's just for mechanics. You cannot reset these circuit breakers in flight, and for that reason, to avoid pilots from touching these circuit breakers, the manufacturers decided to put a red color over that circuit breaker. That's all. And then we have the yellow color circuit breaker I was talking 3 minutes ago, just for the fly on bats procedure. And we're gonna see now, in this slide, next slide, this one, DC power circuit breakers on the all A320s, because we're talking about the black yellow ring sorry, circuit breakers when we are flying on battery only. I hope you can see well on the slide that here we have Python 1 and Adiro 1 angle of attack 1. These 2 circuit breakers are pulled out in the case we are flying on batteries with a dual engine flame out, for example, in the old version of the A320, just to save, as I said before, some minutes more for the battery. So remember, we're 22 minutes, the time we have if we are flying with batteries. If we pull out these circuit breakers on the overhead panel, we can save some minutes more, approximately 7-8 minutes more of flight endurance. In the procedure, if you go through the QRH procedure, you will see exactly, and we will take a look on the type rating of jet orientation course here at GTA, and you can see how it works exactly and how you have to pull it out and push it again, because you have to push the pitot circuit breaker before and after 1 minute the Adiro 1, just to have heating on the pitot and so have a good speed reading in the PFD of the pilots. But just don't worry about that. We want to see in deep during the course. Here I choose this picture because I think they are very good ones. This is for new A320s. As you can see here, we don't have yellow ring on the pitot number 1. As well, we don't have yellow ring on the Adiro 1 angle of attack. So why? Because it's a new plane and they don't have this system again. They don't have the old RAT, so they work in another similar but not the same way. And these are the wingtip brakes we were talking before. Now you can see just 2 of them, the system 1 for slat and flap. Over here in this part, I don't have a picture of that, but we have another 2 for the system 2 of the flight controls wingtip brakes. Good. Now we're going to talk about normal operation of the electrical system, just in the sense of priorities. Who has priorities between the generators? The first one are the generators engine driven. That means that if you have engine working, they are the leaders. If we have external power and we don't have engine, for example, okay, the external power is going to supply the system, but if we have engine and external power connected at the same time, the engines drive the system. That's the idea. Here on the ECAM, you can see that the generator 1 and generator 2 are on. They are giving electricity. They are connected to AC bus 1 and respectively AC 2 bus. And the external power is connected and the APU generator as well, but they are not feeding the system at all because the generators of the engine has the priority. No green line over here. So that means that they're not giving electricity to the system. These are the main three generators we talked about before, the generators engine driven and the APU generators. We have as well the GPU that is external to the plane, that is the ground power unit, external power. And then 4 and 5, we have Air Turbine, the emergency generator, obviously, as we said, is for emergency. So if something here fails, we will use the emergency generator driven by the RAT. And last but not least, the batteries that they are giving as the last option, 22 minutes flight to us. Good. Control indicators, very quick on that. You will see the battery 1 and 2 switches. Remember, Airbus has the philosophy of dark cockpit. That means no lights, means everything is working properly. If we have some light, it could be fault or off. It means that something is not working well, or system is deselected, or we have a failure. Here we have the voltage for the batteries and the switches to switch it down. We will see during the course how to work with them, how to check it, and all the stuff. Then we have the AC essential feed. This is in auto position as well, and you will see an out green light when the AC bus 2 is feeding the AC essential bus. On normal operation, the AC essential is fed from AC bus 1, but if something happens, we will have the opportunity, the possibility, we can say, to have electricity on the AC essential bus from the AC bus 2 with the AC essential feed. If we have a full lights over there, it means that the system is not working properly, obviously. The galley switch over here, some plane has also the commercial push button over here. This is an old A320, so we don't have this push button, but don't worry about that. You will see here at GT8 probably some picture and some overhead panel with the commercial. This is optional stuff for the company, so it's not present in all the planes. The galley with auto position, that is the one we're saying, fault option if something is wrong, and off to deselect the system. EDG switches. Remember, we talked about the IDGs before, integrated drive generators. There are guarded red push buttons. Why they are red guarded push button? Because if you press it, you cannot reset them on flight. That means now they are working because we are out of position. But if we deselect one of the two IDGs, imagine IDG number 1 due to a failure on that engine and the ECAM is requesting us to deselect this IDG, we deselect the IDG and we lose the IDG for all the rest of the flight. So take care with that. It's a guarded push button, so that means that we always have to cross-check with the other, between the pilots, captain and first officer. Both pilots have to be agree sorry, with that action, and whenever you press it on off, in that case, you cannot recover all the rest of the flight, so you need to reset them on ground, and it's a maintenance task. Remember, the IDGs, they're disconnected from its drive shaft, and well, as I said, they can only be reconnected by maintenance. Then we have the generators 1 and 2 switches. To select it on, you will see during the course when the engine are off, a lot of students in the first sessions always surprised because they look the overhead panel and they see fault light on the generators push buttons and they say, hey, something is wrong. No, man, no worries. Remember that the engine is off, the generators are engine driven, so if the engine are off, we have a fault light over there. It's not the same case if we have a fault in flight. That means that something is going wrong inside the generator. On ground is a normal situation to have fault lights over here before starting the engine. Just for you as a tip for the course. And we can deselect them, pressing obviously the off position. APU gen work exactly as the generator number 1 and 2. And then I'm going to lose time over there. The bus tie, that controls the bus tie connectors. You have 2 bus tie connectors over here that transmit AC power from the left to the right hand side and vice versa. And if you need for some procedure to deselect it, you have just to press it in off. If not, it's working automatically in the system. And finally, the external power that is giving electricity to the plane when we are on ground, when we switch off the engines, or when we are waiting to switch it on. We have another little panel on the emergency on the electrical overhead panel, that is emergency electrical power. Here we have the emergency gen test that is used for maintenance to check that the system is working properly with batteries and everything is going good, but it's just for mechanics, so we don't touch this push button. Then we have the Gen 1 line that is used to supply power. Well, it's another way to disconnecting the generator number 1 if we have, for example, smoke in the avionic compartments. So we will practice smoke procedure during the type rating, and we will work with the Gen 1 line push button. And later on, we can see the RAT man emergency generator man on. This is very important, and you will have you will see 2 red guard push buttons like this one in the electrical panel and the other in the hydraulic. We will see later on the hydraulic part. Remember, the Air Turbine extend automatically if we lose both AC power, the main power that are giving electricity to the plane. But if something fails, we have the opportunity to deploy manually the Air Turbine in flight. This is just an example, very easy, generator fault, a generator 1 fault. This is how they can give us the information. Generator 1 fault, you will hear a master caution in the cockpit. Gen affected side off, then on, so we will press this push button and we put it in off. If unsuccessful, it means that fault light goes out, gen affected off. This is how we have the information on the ECAM. Generator has been selected off. Galley shed is automatically set by the plane. That means that some charge of the galley and some system of the plane are shed to save power to the main system of the plane. And this is the FCOM reference. If you see here, it says, if available, the APU may be started and the APU gen used. That means if you lose a generator, you can use well, if you lose the generator number 1, you will have generator number 2 supplying the system, but remember you have an APU, so you can start it. Good, that's all for electrical, guys. Now we're gonna take a look to hydraulic system, section number 8 for today. Hydraulic system structure. Well, we have 3 main hydraulic systems. Green hydraulic system, blue hydraulic system, and yellow hydraulic system. All of them are giving 3000 PSI. And now we are gonna see how it works independently, the green, the blue, and the yellow. Here, as a fast review, you can see that we have the green system that has an engine-driven pump, so that means it is in the engine number 1 as the generator 1. Here in the yellow, we have engine-driven pump for engine number 2, giving us yellow pressure. But if you see, we have other types of pumps. These 2, the blue and the yellow, that are electrics. Blue system doesn't have engine-driven pump, has just an electric pump. The yellow has as well a yellow electric pump in case we lose the engine number 2 or we lose for some reason the engine-driven pump is not working, we can use an electric one. And we have also a hand pump on the yellow hydraulic system that is used by the ground agent to operate the cargo doors from outside of the plane when the aircraft is on ground. And we have also the fire shut-off valve that are used in case of an engine fire or some problem in the engine to save the system. We can close this fire shut-off valve, pressing the engine push button, fire push button. Now we're gonna see indeed. So green system, as I said, engine-driven pumps, fire shut-off valve, and the accumulator or reservoir where the fluid is inside, obviously. Then the blue system that has an electric pump. It works with electricity, obviously, and remember the RAT we were talking about before, ram air turbine, is coupled to the blue hydraulic system, so it permits the blue system to work. And we have also the accumulator reservoir. Yellow system, quite the same as we have seen in the other slide, but remember we have an accumulator, then the fire shut-off valve that we can deselect it. We can close that with the engine fire push button. Then we have an engine-driven pump, electric pump, and hand pump. The electric pump of the yellow and the blue system we can select and deselect from Cockpit. We cannot say the same for the green one because it doesn't have electric pump. Power transfer unit, or PTU, known between pilots is PTU. That's a system that works just to save the green and the yellow pressure all time. Well, exactly is a bidirectional power transfer unit that enables the yellow system to pressurize the green system and vice versa. The PTU comes in action automatically when we have a differential in pressure more than 500 psi between green and yellow system. And we have also some parts, in, well, not some parts, in some, how to say, well, sometimes PTU is inhibited. And this is, for example, when we have the cargo doors are being operated, or we have the parking brake on and just one engine on, so the system is inhibited. Also, if we have the parking brake off, nozzle steering off, and one engine on, and obviously if the PTU switch push button is selected off, because we have a PTU switch button on the overhead panel. So if we have selected off, obviously it's not working. The accumulators, well, normally high pressure bleed air is from the engine number one is the one who pressurizes the hydraulic reservoir automatically. But if this is not working, if engine number one high pressure is not giving pressure to the system, we have another option. Well, the plane takes air from the cross bleed using the other engine. So you're gonna take air from the engine number two if something is going wrong with the engine number one or the system is not working properly. We can take air from the cross bleed duct. Well, now the ram air turbine, we were talking a lot before. Remember, ram air turbine is part of the blue hydraulic system, and it's work automatically when we have a full a dual engine failure, for example, or a complete electrical power lost in flight. So here we have a picture about the ram air turbine. I think here you can see very well. It is in the left-hand side of the belly of the plane, in front of the landing gear, and is similar to propeller. Well, it's exactly a propeller, like a small propeller that with the air impact is giving electricity to it's activating the pump, the hydraulic pump for blue system, and emergency generator for electricity in the aircraft. Now, remember, we have seen in the electrical part the electrical emergency panel, we had the manual on extension for the RAT. And here in the hydraulic panel, we have also an option RATman on. Why we have two red push button switch? For the same reason, you can think. Well, it's not exactly the same. If we press the RATman on the hydraulic panel, we are just activating the hydraulic pump, so the blue system. If we press the manual on extension on the emergency electrical panel, we're gonna have power on the emergency generator as well. So this is the main difference. Remember that the RAT, once it deploys, it can be installed only when the aircraft is on ground. It's a maintenance task, obviously, as you can imagine. And in normal operation, well, if you have a problem, normally the RAT deploys automatically, as I already said. And for example, if we have an AC bus 1 and AC bus 2 lost, we have to be with 100 knots or more. And in the old aircraft, we have to be always with the landing gear up. Now in the new version, this is not needed, but we have to comply with the condition AC bus 1 and AC bus 2 failure and airspeed more than 100 knots, for example. I choose two more pictures about the Ram Air Turbine, just for you to see it better. Here you can see the small propeller very well and the compartment where it is. And here is a plane flight with the Ram Air Turbine extended, as we have seen in the Pakistan International Airline in the last few days. Then we have some picture about the hydraulic architecture. We're not gonna go deep in that, but just for you to know that you have this architecture, hydraulic architecture diagram on the FCOM and the QRH. This one are from the FCOM. We have green, blue and yellow system and all the controls they are actuating for. I like to show this picture just for one thing. Take a look to the old manufacturer serial numbers. We had the nose wheel steering connected in the green hydraulic system. In the new manufacturer serial number, we have the nose wheel steering connected to the yellow one. So that's the main difference between an old A320 and a new A320. I selected as well the graphics diagrams from the QRH, the Quick Reference Handbook that we have on Cockpit, and here we have again the three systems, and you can see the nose wheel steering in the old serial numbers in the green system, and the nose wheel steering in the yellow system in the new serial number. That's why the reason for that is because if we lose the green system, that is the one related with the landing gear, for example, and all the stuff, if we have a problem with the landing gear, with the green system, we imagine we have to extend for gravity, and we don't have the green system to lock and use normal in normal way the landing gear. Well, we still have at least the nose wheel steering with yellow pressure. If we lose the green pressure, we can land extending the landing gear gravity extension, and we will have nose wheel steering on ground. So this is the main reason for this change. Control and indicators, as we have seen for electric, the hydraulic panel is very simple. We have engine 1 pump, that is the green engine driven pump, if you remember. We have the same for the yellow engine 2 pump, engine number 2. We can select it off, if not, it's working in auto. If this pump has default light on, that means that we have a reservoir level low, reservoir overheat, reservoir air pressure low, or we can have a pump pressure low or something like that. And in the yellow electric pump, we can see that we can have, for example, the same failures, reservoir low level, reservoir overheat, reservoir pressure low, pump overheat, pump pressure low. All these cases, we will have a fault light in the engine one pump, in the yellow electric pump, and we have also here the blue electric pump. As you can see, we have a black guarded guard on the blue electric pump. Remember, guarded plus button means confirmation of both pilot. We can switch it on if we need it for some procedure, and if we have a fault light, it means that we are having some of these related problems we were talking about. And then we have the RAT manual on. We talked about before for the manual extension of the RAT if it is not working automatically. And we have as well as push button switch for the power transfer unit to have the option to deselect. For example, if we have an overheat in the yellow or green system, the first thing we have to do is to deselect the power transfer unit manually to avoid contamination on the other system. Imagine we have an overheat on the green one, we deselect the PTU to avoid the overheat of the green system could be transferred to the yellow system. Now we have another synoptic. This is the ECAM synoptic page. We have another graphic picture of the hydraulic system. This is how the plane showed the hydraulic page to us. We have the reservoir over here. The orange limit is the lowest one. This is the good level of the reservoir where it has to be normally. These arrows are going to this green band, so it means that the pressure is and the reservoir is good. The fire shut-off valve, engine 1 and engine 2. This is the engine-driven pump 1, engine-driven pump 2. The electric pump, the RAT. In the case it is connected, we're gonna have a green triangle over here. The PTU and the pressure delivered in the system. I forget to tell you that the Ram air turbine is giving not 3,000 psi of pressure, but just 2,500 psi, just for you to have more information about that. And here, well, I'm not gonna take more time for that, but it's basically, again, the system divided in green, blue, and yellow with the engine-driven pumps, electric pumps, hand pumps, and Ram air turbine. Just to conclude, we're going to see some related events. This is a blue, green, yellow reservoir, lower pressure or overheat. This is what we have on the ECAM. For example, in the case the yellow system has a reservoir lower press, it says if press fluctuates, PTU off, yellow engine 2 pump off. So we need to think about what is happening and probably follow the ECAM, deselecting the PTU and the engine 2 pump off. So we are gonna losing the yellow system, but we are gonna have flight controls via the green and blue system. Then we have a green reservoir or low level. You can see here that the green arrow is not where it has to be, it's over here. That means we have a leak probably. The system is not recoverable because we have lost all the fluid. So PTU again off, because imagine if we leave PTU on and the pressure goes to the green one, we have a leak, we can lose also the yellow. So the yellow pressure, and so to save that, we need to deselect PTU. Green engine 1 pump off. So in that case, we're gonna lose the green system and we're gonna work with blue and yellow. This is a hydraulic engine 2 pump low press, and to see how the PTU pressurize the opposite system if the PTU fails. So, and we have this failure on the pump in the yellow or the green pump. In the yellow system, remember, we still have the yellow electric pump, so we can use it. If it's happened the same on the green system, we don't have electric pump. So we need to extend the landing gear with landing gear gravity extension procedure, as we told before. Good, guys. This is a good sentence of Wilbur Wright. that says it's possible to fly without motors, but not without knowledge and skill. I like this sentence, and we used to show you in all our course, because remember, we can fly, but we need to have knowledge in our mind and skills to apply our knowledge. So it's very important that we continue study and keep studying all the rest of our life as pilots, because without knowledge and skill, we cannot fly probably in the correct way. And the more we can know, the better skill we will have, probably. Well, congratulations, you have completed this part. As I said at the beginning, you don't have to pass an exam, so you can take a relax now. And on just a minute. Okay, here I am. I hope everybody is seeing me. Well, just to say thank you again to all of you for trusting in GTA in these difficult moments. We hope to see you, all of you here in our headquarters in Madrid, in Jakarta, or Bogota. If you're interested in jet orientation course, or probably a TAP rating in the future, we hope to see you soon. And take care in these difficult times we are living. Everything is going to be better probably in the future. I'm sure of that. We need to think in that way. So